Hey guys, welcome to this new video. My name is Aditya and on this channel I talk about Kubernetes, blockchain and software engineering in general. And in today's video I am going to talk about distributed logging. So in any distributed system, observability has three main pillars and they are logging, metrics and tracing. And in this video we are particularly going to talk about logging in detail. So the applications that are running as the microservices, they continuously generate logs and those logs are stored inside the container in the log files. And these messages are called records in logging. All these records are time-stamped and the value is at the time when they were generated. So what to log inside the Kubernetes cluster? Like we have different kind of applications that are running in the Kubernetes. They could be our microservices and we can have logs from the cluster as well, mainly from Kube API server, Kube scheduler, etcd cluster, Kube proxy and kubelet. So all these applications that are running in the Kubernetes, they all emit logs and we can use those logs in order to do further downstream processing or having some alerts or monitoring on the top of them. So one of the popular logging agent is Fluent Bit, and in this video we are going to discuss about the Fluent Bit and its architecture. So Fluent Bit is an open source project under the umbrella of Fluent Bit, which is a CNCF project, and Fluent Bit is completely open source log collector and processor, and we are going to see what this log collector and processor means. Fluent Bit is written in C and it is created to solve some specific use cases that are mainly around those systems which have constraint of memory and resources. So this is how a Fluent Bit looks like when actually implemented. So we have some source that are generating those logs, and those source could be either your Kubernetes cluster, maybe your system generating those logs, maybe Prometheus, or any kind of application that is capable of generating those logs. They act as a input for the Fluent Bit, and then Fluent Bit process those logs and send them to the destination. So destination could be the Elasticsearch, Splunk or S3 or even your Hadoop processes as well. So now let's see how Fluent Bit actually works. So this is a lifecycle over which how our messages are passed from various components in the Fluent Bit. So we have input, we have parser, we have filters, we have buffer, and at the end we have routing. And these routings are capable of sending those messages based on the tags to different output source like Elasticsearch or S3 or some Hadoop processes. So input gathers log from different sources and these sources can be a file or systemd process or collectd process, anything which generates logs. Then we have the parsers. So parsers basically converts those logs that are generated by various application into a structured form. So it could be like JSON or it could be some other form. So those things are handled by parser. Then we have the filter, and filter is basically used for modifying those records. Maybe you want to remove some fields from those records or you want to add some fields to those records. So those operations are taken care by filter. Then we have the buffer, and buffer is used for aggregations and calculations. So buffer process those records onto the memory and then those records are sent to the routing. And routing takes care of sending those messages to their destinations as per your configuration. So if you have configured, let's say error messages should go to Elasticsearch or all the information logs should go to your S3 bucket. So those things are taken care by routing with the help of tags that we associate with those messages. And this is how Fluent Bit actually works in a Kubernetes cluster. Fluent Bit runs as a daemon set in the Kubernetes cluster, and it continuously observes the logs file that are stored within the node and process those log files that are generated by the containers. And then it filters and parses those logs and send them to a destination. So now let's jump into the demo and set up Fluent Bit, Elasticsearch and Kibana and visualize those logs into the Kibana dashboard. So right now I'm in the official website of Fluent Bit, and here if you go to the documentation section and then here search for Kubernetes, so it will land us to the installation page. And here if you scroll down, here we can see some steps that are required for installing up the Fluent Bit. So let's do one thing. Let me just bring my terminal here and let's try to create the namespace. And then we will also create some service accounts, some roles and role bindings. And I will also discuss like why we need these service account roles and role bindings in detail. So I'm in my terminal now. Let me flip the profile. Yeah. So, so I'm in my terminal, and now first we have to create a namespace where I'm going to keep all my Fluent Bit resources. So let's create this namespace. Let me check if my cluster is up and running or not. Yes, so my cluster is up and running. Let me create a namespace. Yes, so the namespace got created. And now let's understand like why we need these resources, why we need this service account, why we need these roles and role bindings. So we need these roles and services to make sure that our Fluent Bit is able to talk to different containers or different resources or different Kubernetes resources in order to collect those logs. So that's why we need these roles. And if we just check the roles, like whatever roles we have, most of the roles will be around the read permissions that our Fluent Bit is able to read those resources. So if I just open this file here, so you can see that the verbs here are get, list and watch. So Fluent Bit should be able to do all these operations within the cluster. So now let's quickly create these roles, service account and role bindings. So let me just run this command, and this is going to create a service account for our Fluent Bit. Yeah, and then similarly let's create the role, and this role has only the read permissions, which is get, list and watch. And the third is we need the role bindings to set up the role binding between these role and service account. So this got also created, and let me clear up this. And one more thing, if you are running this in Kubernetes cluster version 1.2, then you have to follow these steps, but these are for the Kubernetes version 1.21 because I'm running version 1.21, so that's why I applied these configurations. But if you are on version 1.22, then you have to apply these configurations. Now we have to do a couple of more things. So first we have to set up the Fluent Bit as a daemon set. So that daemon set is going to run across all the nodes, and in our case we have 3 nodes, so we should have 3 instances of the Fluent Bit that is running across all the 3 nodes and collecting those logs. So before that we have to create the config map as well, and let's check what this config map holds. So let me just copy this. So basically if I just zoom in, so here we can see that this has some configurations, and these configurations are around the input source, the filters, the output destinations, and basically the parser. So we discussed about all these configuration in the previous part, but now we are actually going to see the implementation of those. But I'm not going to directly apply these configuration because this has a lot of configuration, and to make it much more simpler, I have trimmed down some of the configuration to make it easy for you to understand, and we're going to apply that configuration only. So I have that configuration in my local system. Let me bring those configuration. So this is the configuration. This is the same configuration file that I took, and I just trimmed out some part of it. So the important part here is first is the input section. So let's discuss the input section. So input section talks about like what should be the source of logs in our Fluent Bit. So first is the name. So here we specify the plugin name. So the name of the plugin that we are going to use is tail, and it should collect the logs from this location. So Kubernetes generally stores all the logs, all the container logs in this location, and here we have kept asterisk, which means here we are doing some regex magic that it should capture all the log within this folder val log containers, and that is going to end with .log. Then we are going to put some parser, and we want to parse those logs using the Docker parser. Then we are tagging up those logs that are captured by this input section with this name, with this as the tag, and here we're specifying some memory buffer limit and skipping long lines. So let's go to the official documentation and take a look on this plugin as well. So if I go to Fluent Bit official website and if I here search for tail, it should list us the input plugin, tail input plugin. Here you can see, and you can see all of the options that we have used there. So you can see we have path. If you want to exclude some specific files, you can keep them in the exclude path, maybe like ZZ or zip files. And then you can see the bunch of other options and you can apply those configuration as per the requirement. Now let's jump again to the file, and here you can see that I have one another input source which is the systemd, and basically this is the plugin name which is systemd, and here we are tagging all the systemd logs with this tag which is host dot and then asterisk, and then here we are using some filters, and then we are specifying that it should read the logs from the tail. After that, let's discuss some parser part. So here I am using two parsers. So the first parser is the Docker parser, which processes those logs into the JSON format. And then here we are also specifying the time key as time, and then we are specifying the time format. So if you want to see more about this Docker plugin, you can simply go to the Fluent Bit official website here, and you can search for Docker and it will give you the Docker plugin. Let me search for Docker plugin. Rather, it should be a parser. This one. So you can see we are parsing the logs, and these are the same fields that I have also used. So these are those fields. One other thing that I wanted to show you is this output section. So here we are specifying the output or the destination for the Fluent Bit, that where it is going to store these logs. And here we are specifying the name as ES, which is output plugin, which is Elastic Search. And then we are keeping the match. So it is only going to store those logs into the Elasticsearch, which has a tag of cube dot asterisk. And if you see the input section as well, here we have done the tagging that all the logs that are coming from this source, they are going to be tagged with cube, and all the source that are coming from systemd, they are going to be tagged with host. Then here is we are specifying the Elasticsearch host and Elasticsearch port, and then here we are giving the index name. So I want to in the Elasticsearch I am keeping the index name as my index, but you can keep anything else you want to put. So this was it for this part, and now let me just apply this configuration. So let me just do kubectl apply, and the name of the file is Fluent Bit config map. Once this is done, we can also deploy the Fluent daemon set. And what I have done, the configuration for the Fluent Bit daemon set is also present in the official docs. And after that, we have to set up the Fluent Bit. So either you can use this YAML or you can use the Helm chart and set up your Fluent Bit. So what I'm going to do, I'm going to take this YAML file and then deploy it in my Kubernetes cluster. So if we just go and take a look, so this is a daemon set. Here we can see that this is a daemon set, and this has some configurations as well. Then basically we are specifying the Elasticsearch host, the Elasticsearch port, and we are also specifying the mount path of the host machine where this daemon is going to run, the container is going to run. So let's apply this, and I have already this file in my system. So this is the same file that I have taken from the official docs only, and let me apply this. And one more thing, so here you can see that we are passing the environment variable Elasticsearch host and Fluent Bit port, and this same environment variable we are referring in the Fluent Bit config map as well. So if I scroll down, here you can see that we are receiving those these values from the environment variable. So let me just apply this, and this is the daemon set. Yeah, so it got created. Let me just do get pods in logging namespace. So it is waiting for it to create, or let me do q hyphen a. So it is still in creation phase. So also we need Elasticsearch and Kibana in order to visualize those logs. So what I'll do, I will simply use the Helm to install the Elasticsearch and Kibana. Let me clear up this. Let me do Helm install Kibana, and then I will install the Elasticsearch as well. So Kibana got installed. Let me do Helm install Elasticsearch. So this is going to install the Elasticsearch. And one thing we have to also do is we have to configure this host, because I don't think so that we are using the correct host here, because this Elasticsearch service is going to be created in the Elastic namespace. Let me just try to fetch all the services. Yeah, so we have the service that is in the default namespace, but the service name is Elasticsearch Master. So what we have to do here, we have to just simply update the name, and let's check the namespace. So the namespace is default. Let me give the namespace here as well, default. Yeah. So now if I just delete the daemon set and apply it again, it should, first I have to delete it, and then I can apply the correct path, correct environment variable. So apply. Yeah, so it got created. Let's wait for it to finish. So our Elasticsearch is also in creation phase. Kibana is also, it is also creating, and they all are in running state, but now the Fluent Bit is in creation state. Let's wait. So let's do the port forwarding for the Elasticsearch meanwhile, and check if the indexes are getting created or not. So I will do kubectl port forward Elasticsearch, and on the port 9200. Let's check in the browser what all indexes do we have. 9200/cat underscore indexes. So it has no such index with name my index. So let's wait. Let me split my terminal here, and let me check if Fluent Bit is up or not. So it is still in creation phase. Let's check what is going wrong here. So it is waiting for container creation. So let's check again. The namespace login. Okay, it should be logging only. Yeah, so here we can see they are up and running, and now let's try to refresh the indexes and see. Yeah, so here we can see we got our index, which is my index, and now we can use this my index into the Kibana and do the visualization of those metrics and logs. So let me split this terminal and let me do the port forwarding here for Kibana. Port forward for Kibana, which is running on 5601. So let me go here, localhost 5601. Kibana is also ready. Now let's go to the stack management and then index patterns, and let's create the index first. So create an index. You can see the index is appearing here. I will call it as my underscore index. Then for the timestamp field, I'm going to use @timestamp, create index pattern, and then these are the fields that are captured in those logs. Now if I go to discover, I should see some logs. So it is searching, and we can see that we have logs here. We have logs, and these logs contain some messages, some lot of fields. Here we can see that it has the fields, but we are missing some information, mainly on the, like, we have the information and the logs here, but we are missing on those parts, like where this pod is actually running, what's the name of the container, what's the image, and all those things. So for this we can use one of the filter, which is for the Kubernetes, which will extract those metadata and add it here. So let me do one more thing. Let me just update that config map. So if we go to that config map, let me add that property here. So let me put that filter here, somewhere here. I'm going to put that filter, and basically this filter is going to match to these kind of logs, and then it is doing the merging. So whatever logs it has received previously, it is going to do the merging on them. Then we are keeping the labels on, which means that our application that has though all the labels specified, they will also be captured. Annotations we are keeping off, and then we have some log parsers off, and logs logging as well is exclude off. So you can read about these filters from the plugin documentation. And now let's try to apply this and restart the Fluent daemon set. So let me open my terminal here. Let me apply it. kubectl apply the config map, and then we are going to restart the daemon. So now let me do kubectl delete Fluent Bit daemon set, and then I will apply it again. It got deleted. Let's apply it. Yeah, so it got applied. Let's wait for those details to come up here, and let's do one more thing. Let me delete the index as well, and I will recreate the index. So if I go to index pattern, right now we can see we have only these many fields. So let me just delete this index pattern, and I will create it again. So let's create the index pattern. We have the index here, my underscore index. Let's add the timestamp field here, and let's click on create index. So this time you can see we have 54 fields, and you can see we have fields around the Kubernetes as well, like Kubernetes container hash, container image, and all those things. We have labels as well, we have host as well, we have all those details. And now let's go to the application, go to the discover tab, and here let's try to visualize those logs. So if I open any of the log, you can see we have the bunch of detail as well around the Kubernetes, like where this node where this application is specially running. So we have the node detail as well, the container image as well, the image hash, the container hash, the container ID. So all those things we have here, and we have captured all those details. So this was pretty much it for this video. Hope you like this video, and if you did like this video, then please give a thumbs up and subscribe to the channel, and I will see you in the next one.